Okay, good morning. Welcome to
Math number 136.
Math number 136. I'm going to write on this problem because this is kind of a long problem, but it's a very cool problem actually. Great chance to get some arithmetic practice. And it's from the Mathematical Association of America's Minute Math page. You ready? Mm-hmm. And by the way, you always like to know, only about 20%, 1 out of 5 people got this right. The number 64 has the property that it is divisible by its units digit. What does that mean?
It means 64 is divisible by 4.
Very good. How many numbers between 10 and 50 have this property? Okay, so they gave you an example, 64 is divisible by 4, and they asked how many numbers, sorry, they meant how many whole numbers, how many integers, I just didn't write it right, have this property. Okay, so how would you approach a problem like this?
Well, we could find a few.
We could find a few.
Well, I know that 11, 21, 31, 41. These are divisible by their units digit.
Okay, so the ones that end in 1, there's 4 of those. Very good job. That's a great way to start.
And the ones that end in 2.
Okay, 12, 22, 32, 42.
Yep.
42 also have that property. Okay, but good start.
Well, the ones that end in 3.
What am I doing?
Only one of them.
13, 23, 33, and 43. Okay, only one of these works. How do you know that?
Well, because 13 is prime, 23 is prime, and 43 I think is prime.
Seems like most numbers that end in 3 are prime. Think that's true?
Maybe.
Probably not. Alright, good. So only one has that property, 33. Alright?
The ones that end in 4.
14, 24, 34, 44.
These 2.
There's 2. Okay, awesome.
Ones that end in 5. It's going to be 50. They're all divisible by their units digit.
Okay, how do you know that?
Because you can check.
You can check. They all end in 5, so they're divisible by?
5.
Okay, so 16, 26, 36, 46.
Well, 36 is divisible.
Only 36. All right. 17, 27, 37, 47.
Which one? None of them.
None are divisible by 7. That's interesting. 18, 28, 38, 48.
Well, 48.
48. 19, 29, 39, 49.
And these ones, 49, none.
None again. Okay.
Actually, what about the ones that end in 0?
What about the ones that end in 0?
10, 20, 30, and 40.
Okay.
But none of them are divisible by 0.
Why not?
Because something that's divisible by 0 is 0.
Right. You can't divide You can't divide any numbers by 0. 30 divided by 0 is what?
Just 0. No.
Not defined. You can't divide by 0. So none of those numbers are divisible by 0. So how many are there?
There's... It's going to be 8, 9, 11, 15, 16, 17.
Awesome. Good job, sweetie. Good job. That's a very challenging problem. And your way of doing it, nice and systematically, I really like that way of doing it. And you know what the hard part about a problem like this on a math contest is? So this came from that math contest?
What?
You gotta go fast. So, and when it's on a contest, you gotta go fast.
This math counts where you have to go like...
It's an AMC8 problem. But, so, this is a great job. I don't care if you go fast or not go fast. On a math contest, this is a little harder, but your way of doing it was super duper.